Sige po.
Hello, good evening. Good evening, everyone. Welcome to another edition of Even Learning. Thank you for joining us today for the first of the ACMV series. So we're going to talk for the part one would be the overview of heat load calculations. We are glad to be with you and we're glad that you're joining us and participating in this training. This training is brought to you again by Even Learning. We provide quality trainings and seminars conducted by your peers. For tonight, the start of a series, ACMV series. So there's going to be a five-part. This is going to be a five-part series. So this would be the first. Please tune in to our Facebook page, Even Learning page, Facebook page. So you will be able to see when the other parts will be coming out. So we'll post them as soon as possible. This training will be held for approximately an hour. So 1 hour tayo, including questions and answers. As we go along the training, if you have any questions, feel free to use the chat box to write your comments or unmute yourself and interrupt me and say anything that you would like to say. We will get to them. Those that are in questions, we will get to them as soon as possible, or at least in the Q&A session. If we still aren't able to get your questions, we will get back to you after the training session, and you can send me an email via evenlearning.sg@gmail.com. Okay. So we will start for our series, the overview of heat load calculation. Sa mga bago, so those who haven't known me yet, hi, my name is Don Gabriel. I'm a professional mechanical engineer specializing in ACMV, so air conditioning and mechanical ventilation. ACMV is a term here being used in Singapore. In the Philippines, I think they use MVAC, mechanical ventilation and air conditioning. I'm a graduate of Buwa Institute of Technology with a degree of Bachelor of Science in Mechanical Engineering. I got my PME in 2016 and my MBA last year from AMA University. I started my career way back in 2001 as an ACMV designer for RJ Calpoint Partners. And I started to work overseas in 2005 and moved to Singapore somewhere around 2009. So again, if you have anything you'd like to say, any comments, any questions, I can be reached through my email at evenlearning.sg@gmail.com. And my mobile number is listed down there. So if you want to say anything, drop me a call, drop me a line, drop me a text. My number is below. Okay. So we will start. Overview of heat load calculation. For this training, we would learn three things. First, we will define sensible and latent heat load. Second, we will determine the sources of these heat loads and some sample calculation. How are we going to calculate this? And of course, rules of thumb. So rules of thumb is not an actual guidelines, but it is a guideline to make sure or to at least direct us if we are correct in our calculation. Okay. All right, so first, defining the sensible and latent heat load. Sensible load. Sensible load is the amount of heat or the heat load that can be sensed, meaning nararamdaman nyo. It can be defined or it can be shown or it can be manifested through the increase of temperature. So there's a rise and fall of temperature. If the temperature is 20 become 21, then you would know there's an increase of heat because it was sensed by a thermometer. So there's a sensing, sensing sensation. So you'll be able to sense if there's a rise or fall in temperature. You could feel it and you could quantify it through the rise and fall of temperature. So that is sensible heat load. Another one is the latent heat load. Latent heat load is the increase of heat without the rise or fall in temperature. So we can observe this increase of heat by the change in phase. Example is this ice. The ice is melting. The water here around is 0 degrees Celsius. The ice is also 0 degrees Celsius. There's no change in temperature, but the water is changing in phase from solid to liquid due to increase in heat. That heat is characterized by latent heat load. Right? Question? Question so far? Wala pa? So there's two types of heat load, no? The sensible heat load and latent heat load. So how does it equate in our air conditioning? Okay. So we will determine the sources of heat load and its sample computations. So this is a typical office. Let's say office A. So here in office A, there are sources of heat. There are heat being generated inside the office. So what are the heat generated inside the office? The heat generated are, ito. I divided them up into sensible heat and latent heat. Okay? The sensible heat, there are a few. Radiant heat load, conductive heat load, equipment, lighting, occupancy, and outdoor air. So latent heat load naman, there's the equipment heat load, the occupancy, and the outdoor air. So these are the two types of heat load, sensible and latent. And these are the things that can be found inside your typical space. So sa space na ito, on this typical office space, you will be able to find this type of heat loads dito. And when we quantify, and then when we quantify this, we will get your total sensible and your total latent. If you combine them together, this is your total heat load. Ang title natin ng heat load calculation. So we will define each and every one and how are we going to calculate these items. Of course, these items also. Medyo malinaw? Okay pa? Wala pang question? All right, we will continue. So first, radiant heat load. Saan mo makikita yung radiant heat load? Radiant heat load can be measured through the walls, through the windows, and through the doors. Anong ibig sabihin ito? By the word itself, radiant, ibig sabihin, ito yung tama ng araw, or this is the rays of the sun, and having this radiant heat going inside the ventilated space or the air-conditioned space. So example, no, this is your window or your door or your wall, whatever it may be. Tatamaan niya ng araw because of natural daylight. Because of this light coming from the sun, hitting your building or your facility or your facade or your wall, some of the energy, some of the radiant energy will be transferred to the wall or to the window or to the door and be radiated inside the office space. So let's say this wall orientation is west side, north side being this way, the The area would be 2.4 by 4.2. Total area, square footage, is 10.1 square meter. What will be the radiant heat coming from here? Now, when we do radiant heat calculation, we consider a few things. We would consider, of course, the location. Asan ka ba? Sa Manila ka ba? Nasa Davao ka ba? Singapore ka ba? Season. Ano ba yan? Tawag dito? Tag-ulan? Tag-init? Baka naman 4 seasons sa inyo. Or baka naman taglamig. So you consider the location, the season, the angle of radiation. Ibig sabihin, kung anong araw mo siya, anong oras mo siya kinonsider. Alas 3 ba ng umaga? Alas 4 ba ng hapon? Siyempre, if the north is here, in the morning time, there's not much radiant heat here. But in the afternoon, there's going to be a lot because the sun will be facing on this side. And of course, kailangan natin makuha yung solar factor. Ibig sabihin, solar factor, meron ka bang awang? Or meron ka bang tawag dito, tinted na? O meron ka bang special paint na nilagay doon sa pader mo to decrease the radiance coming from the sun? Meron yung awang mo, ito yung shading factor mo. Meron kawang katabing building o meron kang puno dyan. So, merong anino. So, hindi lahat ng araw mo tumatama doon sa pader mo. And of course, yung coefficient of heat transfer. This coefficient of heat transfer is dependent on the material that you're going to use. Would this be a glass? Would this be concrete? Would this be bricks? Okay. Because this radiant heat is dependent on so many factors, your location, your season, radiation, solar factor, material, building materials, and your shading. Let's just say it is not how do I say this? It would take us a long time to calculate how much heat is coming from the sun going inside the building. As for now, because of this complicated procedure, well, it's easy to use spreadsheets or software calculations to reduce the time involved in calculating the total heat generated through radiant. Okay? So, ano muna tayo, no? Medyo cheating muna tayo. Because of these all factors, hindi natin kakayanin na pag-usapan ito within 1 hour. So at this moment of time, we will just say that we have calculated this using spreadsheets or computer software and was able to deduce that the radiant heat we are getting is about 513 watts. Okay? So, dahil sa sikat ng araw, i-consider natin for the whole operating hours ng office na to is the office's location, the season, angular radiation, solar factor, heat transfer, and shading factor. And we were able to calculate using our spreadsheet and software and got 513 watts. Okay? Okay. Next. Next is conductive. So meron tayong una kanina, no? Radiant heat load. So radiant heat load natin 513. Now we are going to use conductive heat load. What is conductive heat load? Conductive heat load can be seen through the ceiling, through the floor, and through the partition. So conductive heat load is different from radiant. Anong ibig sabihin ito? Kapag conductive ka, ibig sabihin you're still within the same space. However, the other space is not air-conditioned. And this one is air-conditioned. So yung other space mo na not air-conditioned will be generating heat and it will be radiated to the indoor space. Okay. So hindi mo na kayo kinoconsider yung sikat ng araw. So there's no more time consideration, there's no more location consideration. There's none of that anymore. What you're only considering now is the conductive area between the non-air conditioned space and the air-conditioned space. The formula to get this one is this one. Q is equal to UA delta T, where Q is your heat load, A is your surface area, so this one, the whole red line. So assuming that this one is 4.2 meters in length and 2.4 meters in height, so total of 10.1 meters. And the delta T. Delta T of outside, other side, and versus your indoor space, your air-conditioned space. So how are you going to do that? Okay. So ito yung formula natin, no? So we will substitute the values for each. So Q is equal to AU delta T. A is your area, so ito yon. Ito yon, 10.1 meters squared. Itong U or yung coefficient natin, thermal coefficient natin, ito yon. Insulated partition dependent on the material used here, construction material. So we assume that this one is insulated partition. The U value for the insulated partition is about 0.18 watts per square meter per Kelvin. Kelvin is your change in temperature. So saan ang galing itong 33? 33 is from the indoor space of the non-air conditioned space temperature. Yung 24 is the design temperature within your indoor space. So the difference between that will be delta T. So you multiply all these numbers, you will get about 16 watts. So ayun na, no? Meron tayong dalawa. First is yung radiant natin, second is yung conductive natin. Pangatlo, equipment. So, sa loob ng aircon office natin, there are equipments that are running. And because of this equipment are generating heat as they operate. So, example ito, yung mga printers natin, yung mga plotters natin, o yung mga computers natin, these are equipments that are generating heat. So how are we going to calculate the heat generated by the printers and the plotters and the computers? We use the formula Q is equal to A usage density times diversity factor. Okay. Where Q is your heat gain, A is your floor square footage or your floor area, and usage density and diversity factor is self-explanatory. So natin makikita tong usage density and diversity factor. Where can we find the value that we go to substitute for this one? The values can be found at ASHRAE. So I'm using ASHRAE 2017 Fundamentals Handbook. Okay, table 11. So here I have type of use. I chose 100% desktop, heavy usage with 2 screens. Load factor is 11 watts per square meter. Okay. Or diversity with a diversity factor of 75%. Ibig sabihin ng diversity factor, yung load mo, itong load na to, which is 11 watts per square meter, ito yung wattage mo, ayan. Hindi naman 100% umaandar yung TV, yung computer mo, at yung tablet mo. Minsan mag-break ka, di ba? You take a break, Yossi break, or coffee break, or Milo break, or sometimes lunch, di ba? And those equipment will not be used. Medyo idle siya or low energy savings mode. That's what this diversity factor is all about. It's saying that this computer is only being used 75% of the time. The other 25% is when you're on break, or nag-restart, or nag-sleep mode muna kasi natulog ka, or umalis ka, you're away, and then, it took a while for you to come back. So that's the diversity factor. So going back to our formula, Q is equal to A usage times diversity factor. A is 18 square meter. 18 square meter is yung floor area natin. Okay, 4.2 by 4.2, this is 18 square meter times 11. This 11 is nanggaling siya dito. Ayan. 11 watts per square meter. Using this desktop with 2 heavy screens, heavy usage, times 75% diversity factor. What we're getting is, if you multiply all these numbers, we're getting 148 watts. So that's the third sources of heat natin, no, yung equipment. So sa equipment natin, we're able to get 148 watts. Eh sir, paano naman kapag hindi computer yung ginagamit namin o hindi kami nagpa-plotter? Meron kami iba't ibang klaseng equipment. Halimbawa, hindi naman kami office but we're on a laboratory area or in a hospital. Okay? So you can get the heat load or heat generated by your equipment through these tables. Okay? So kung alam mo yung motor, kung alam mo medyo malaki, alam mo yung size ng motor, you'll be able to determine or assume or calculate yung heat dissipated by those motors. Or kapag naman na laboratory ka, may mga typical laboratory equipments found in table 7. All these tables, all these data are available in the ASHRAE Handbook Fundamentals. ASHRAE Fundamentals Handbook. There you go. 2017. My reference is 2017. ASHRAE, what do you call this? ASHRAE updates their handbook every 4 years. So I got this at 2017. Most likely, hindi ko alam 2021 na. There should be a new one, but I haven't seen it yet. I don't have a copy yet of this 2021 Fundamentals Handbook. Okay? Questions so far? Nakatatlo na tayo. Question? We have touched the radiant heat load. We have touched the conductive heat load. We have touched the equipment heat load. Kung walang question. Next is lighting. Lighting heat load. All right. Because of this office, we need to put lights. And lights is one of the more significant contributor to our heat load. So sometimes yung room mo or yung area mo, mayroong decorative lighting or functional lighting, depende sa lux level. How are we going to calculate for the heat load generated by the lights? The heat load generated by the lights can be calculated using the formula QA lighting density, where A is the floor area again. So again, ang basehan natin yung floor area, no? Based on the floor area. Floor area will give you a lighting density. So that's where can we find these lighting density numbers? The values for this lighting density can be found in ASHRAE, again, Fundamentals, Table 2. This will tell you what is the lighting power densities using space by space method. So they will give you they will give you the type of usage or the type of space, and they will give you the lighting density. So which means office, ang lighting density niya ay 12. Meaning you need 12 watts per square meter for your heating capacity. So this area, the office, will generate, its lighting fixtures will generate approximately 12 watts per square meter. Okay. So, balik tayo sa formula natin. Q is equal to A lighting density. A is the 18 square meter. This is the floor area. Okay. Times 12. 12 is from here. ASHRAE table 2. Okay. You multiply them together, you get 216 watts. Question? Next. Some of the lighting heat gain parameters for typical operating conditions. Another alternative from using table 2, you can use table 3. Table 3 is the lighting heat gain parameters for typical operating conditions. So if your room is not specified here, it may be specified according to your operating conditions. Okay, and you can refer to this table 3 for your lighting densities. Alternatively, next is occupant. So this office, no, you will have different people working inside, and as people work, their bodies generate heat. So there are two types of generation, no? When male at saka female. So yung male occupant at saka female occupant, they generate different types or different amount of heat. Okay? So here, first we need to consider how many or uh, how much people are going inside one particular space. So the formula for occupancy heat load is Q times occupant density times the heat generated by the occupants. The occupant density can be found in there. Occupant density can be found in table 6-1 in ASME standard 6.2, 2019. So here in the office space, the code is saying that for every square meter or for every 100 square meter of office area, there will be 5 occupants. So this is our occupant density, 5 people per 100 square meter. And these 5 people will generate this amount of heat. Okay. So we're not earlier we have said that male and female will generate different types or different amounts of heat. As you can see, they're not much different, but we will assume this much. So here on our calculation, we will not be differentiating male and female, no? Whether it be male or female inside, we consider it all together as one generating person. So sensible, about 70 watts per person. Latent, about 45 watts per person. So we're going to use this number. Okay. All right. So here, occupant density natin. So occupant natin, sabi natin, 5 per 100. So because we have our floor area, makikita natin dito, there's already 3 people. So we will consider the quantity of 3 persons inside our small office space. So these 3 persons will generate 70 watts and 45 watts. Balik tayo dito sa kabila. 75 watts and 45 watts. Paano natin nakuha itong 75 and 45? Bakit natin ito napili? Kasi they are seated doing very light work. Kung natin yung picture natin kanina, no? These people are seated doing very light work. But if these people are like this one, the one that are standing up, they will be considered moderately active office work or standing and doing light work, and they're walking. So these are the typical areas where these types of activities are being done. So since our office, these are people, most likely they are seated doing very light work. That's why we have chosen this one, this parameter. Typical to office buildings. Okay, they are seated, doing very light work. So these are the heat generated by these people. So these 3 people, these are the heat generated when they are sensible, and this is when they're latent. Okay. So total for sensible is about 210 watts. Total for latent, yeah, that's why it's called QL. Heat load on latent side, 135 watts. Heat load on sensible side, 210 watts. Question so far? Question? Wala naman? All right, let's continue. Okay. Last but not the least, another source of air is the outdoor air. People inside the office are going to breathe. And as they breathe, they will inhale oxygen and exhale out carbon dioxide. Now, this carbon dioxide in a time frame, if we let it, after some time, the carbon dioxide concentration will increase, and it won't be suitable for human occupation already. So what we need to do is to purge them or to dilute this carbon dioxide with outdoor air. However, By the word outdoor itself, it's hot air. Because we're introducing this hot air, the heat inside this room also increases. That's why we need to consider the heat generated by this outdoor air. Okay. So there's two types of calculation to determine the outdoor air. First is by the occupant requirements, and second by the space requirements. Anong difference ito? Okay. First, yung occupant requirements. Occupant means because there's a assumed number of person inside, each person would require a specific amount of fresh air for them to breathe. Okay. The other one is space. Okay. Because we need the space to be reaching its required IAQ or indoor air quality. Yung pagpasok mo ba sa kwarto hindi masangsang yung amoy or hindi mabaho or hindi stale yung hangin. Diba? To prevent those things, we introduce outdoor air into a building or into a space. So ano ba yung mas kailangan natin? Yung space requirement ba? O yung occupant requirement? Okay. So let's calculate both. First, yung occupant requirements. So again, kanina pinag-usapan natin yung density, no? Okay. So because of the density of the people, we would know how many people are needed, and we can multiply it by the number of air or the airflow rate required by each person. Again, this table 6.1 or 6-1 can be seen can be referenced to ASHRAE standard 62.1 2019, right? So in this table, this ASHRAE is saying that each person need about 2.5 liters per second to be able to breathe properly. Okay, and the room would also need 0.3 liters per second per meter squared. So without consideration to the occupant, without consideration to the equipment inside, the room needs about 0.3 liters per second per meter squared so that it will attain an acceptable indoor air quality. Okay, so let's calculate both. All right. So if you're using occupant requirements, no, again, we have three numbers of people. So these three people would need about 2.5 liters per second per person. Total, 7.5 liters. Pag naman space ang kinonsider natin, space is about 18 square meter. The code said we should use 0.3 liters per second per meter squared. Ang total niya, 5.4 liters per second. Since pag area ang kailangan, ang consider mo, you only need 5.4. However, if you're using people, you would need 7.5. We would consider the higher number. If you're already using this, which means you already comply to this. So we use the higher number. Which one is more higher, the space requirements or the occupant requirements? So we satisfy both requirements. Okay? By using the higher number, we are able to satisfy both requirements. So ayan, nakuha na natin. Nakuha na natin na kailangan natin ng 7.5 liters per second of outdoor air. Now, this outdoor air, the 7.5 liters per second of outdoor air will generate heat. How much heat does it generate? Okay. Because I am from Singapore, I am using Singapore standard. Singapore standard said 32 degrees dry bulb temperature for our outdoor condition, and our indoor condition should be 23 to 25. Our design earlier was 24. Okay, please check if you're in the Philippines or in the Middle East. Please check your local standards. If not, you can use international standard, but first comply with the local standards. So here in Singapore, the local standard is 32 dry bulb for outdoor and 24 degrees for indoor. So if you plug in these two numbers, this 32 and 24, we are able to calculate the outdoor air heat generated. So the formula is Q sensible. So we're just talking about sensible because of these sensible temperature readings. Okay. The heat load sensible is the flow rate, air flow rate, times the specific heat of air times the temperature difference. 7.5, this is what we calculated, required by the 3-person. This is constant, 1 kilojoule per kilogram per Kelvin. This is the specific heat of air. And this is the outdoor temperature condition. This is as per Singapore standard, 32. I think in the Philippines it's 34 or 35, 32. And the indoor, the office design temperature is 24. So you plug all these numbers and you get 72 watts. But this is only sensible. We still have latent. So for the outdoor latent heat, okay, this is the formula. The formula is latent heat of evaporation and difference in humidity ratio. So similar to the other formula, where the latent heat load is the airflow rate times the latent heat evaporation of water times the difference in humidity ratio. Okay. Where are we going to get these numbers? We're going to see the difference in humidity ratio. Okay, we're going back to this standard, saying our outdoor air is 32-degree dry bulb, 26-degree wet bulb. This is the outdoor air, so this is constant. Our indoor condition is this one, 24 degrees Celsius, in between 23 and 25, but not exceeding 65% humidity. So let's say 50% humidity. This is the common one for common design parameters. 24, 50 degree humidity, 50% humidity, sorry. If we plot that on the psychrometric chart, this is the 32 degrees Celsius, 32, 31, 32, and 26, the intersecting point. You're able to calculate the humidity ratio. So the outdoor air humidity ratio is about 18.89. For the indoor air, our design, this is 24, and this is 50% RH. The intersecting point will give us the result of 9.34 grams of water per kilogram of air. This is our humidity ratio. So outdoor humidity ratio, indoor humidity ratio. So now we can plug these numbers into our formula. Ito siya, 18.9 saka 9.34. This is our humidity ratio. This specific, ang pangalan niya ay latent heat of evaporation. This latent heat of evaporation is constant. Okay? Parang specific heat of air lang yan. Constant to, hindi ito nagbabago. So the flow of air, we calculated for these 3 people that they needed, times this latent heat of evaporation, times the difference in humidity ratio, will give you about 211 watts of latent heat. Okay? Going back to our slide from the beginning. Okay. We said the office would have 2 sets of heat load, the sensible heat load and the latent heat load. Okay. Last natin pinag-usapan yung calculation ng outdoor air sensible at yung outdoor air latent. So these are the heat load that are sensible and these are the heat load that are latent. We will combine them together to get the total sensible heat and the total latent heat. And as we combine them together, we will get the total heat load. Right. So tingnan natin, no? So sabi natin yung total outdoor air latent heat load QL is about 210 watts. So pag nilagay natin siya sa lahat-lahat na, ito na yun, 210 watts. So ito na yung total natin, no? Total sensible heat load. Yung radiant natin, yung conductive natin, yung equipment natin, yung lighting natin, and this is the occupancy, yung mga tao, and this is our outdoor air. So masin nyo, no, doon sa equipment natin, wala tayong latent heat. Doon sa table, wala nakalagay na latent heat load. There's no latent heat load for the equipment. So sensible. Sometimes there are equipments that produces latent heat load, but in our case, the plotters and the computers don't have a latent heat load. So that's why our latent heat load here is 0. Okay. So again, this is the radiant heat load that we use Excel spreadsheet and computer software that giving us 513 watts. We have our conductive heat, the difference between air-conditioned space and non-air conditioned space will give you 16 watts. 148 watts is for our equipment. 216 watts is for our lighting. 210 watts is the sensible for people working in the office. And 72 watts for the air needed by these people to breathe. And this 135 watts of latent heat load is given by the people. Ito yung ano, pag nagpapawis tayo, pag pinapawisan tayo, nagtatrabaho tayo. At ito naman, yung outdoor air. This is from the latent heat load from the outdoor air. And if you total them together, you get 436 watts, and if you total them together, you get 1.17 kilowatts. All right. Question. Question so far. Wala naman? Okay. Tuloy tayo. So, when you total the sensible heat load, there you go, sensible heat load, we have earlier calculated 1.17 watts. Yung 346 watts, ito yung total latent heat load natin. If you combine them together, 1.5 kilowatt, it will be our total heat load. Now, sometimes we are using sensible heat ratio. What is sensible heat ratio? Sensible heat ratio is the total sensible divided by the total heat load. So total sensible divided by total heat load. Okay. Sensible heat ratio is 1.175 and 1.5 kilowatt. You will get a sensible heat ratio of 77%. So meaning at this 1.5 kilowatt, 77% of it is sensible. The rest would be latent. Why is this important? This is important because of the equipment selection. So when you look at your equipment, you would see their total heat load. Okay? When you select an equipment, for example, bumili kayo ng aircon, no? Yung split type. Nakalagay doon. Kailangan ito, ang kaya nito is 2 horsepower or whatever kilowatt or whatever watt it may be. Sabi niya. But you have to check yung sensible heat ratio or yung sensible load na kaya niya lang. It may be 1.5 pero ang sensible nilang pala is 1,000 or 1 kilowatt. The 500 watts would be latent. Yari ka pa din. Undersize ka pa din. Okay? So sometimes medyo tawag dito. Medyo interchangeable ginagamit minsan mga tao, interchangeable yung total sa sensible. Kasi ito lang nararamdaman nila eh. Hindi na nararamdaman ito eh. So that's why sometimes they just use this one. But no, sensible heat ratio is it's the ratio between the sensible heat and the total heat. You need to check this one and check this one when you do equipment selection. Question? Wala pa rin? Okay. Last one. Rules of thumb. Ano itong rules of thumb? Rules of thumb is, balik tayo dito. Siyempre, no, itong office na ito, hindi naman ito first time na nag-calculate tayo ng office. There are millions and millions of offices already installed with air conditioning calculated by different engineers. They are compiled and measured. So pinagsama-sama. Pag pinagsama-sama mo yung mga offices ngayon, napansin nila na ang total heat is usually about this much to this much, average of this much. Yun ang kailangan natin sa rules of thumb. Yung ibang mga offices na na-install na, pumapatak usually sila sa mga numbers na ito. Yung total heat load nila nandito sa range na ito. So mapapansin ulit, no? Yung total heat is different from sensible tsaka sensible heat ratio. So yung sensible heat ratio nag-iiba-iba from 0.73 to 0.93. Okay? So double check ulit, no? Check natin yung calculation natin. So kanina sinabi natin, ang calculation natin is 0.77 at saka 1.5. Asan ba tayo? 0.77, ito yung sensible heat ratio. Nasa medyo mababa tayong side. Nasa low side tayo. But we're still within the range. 0.73 to 0.93. Ganun din sa total heat load natin. No? This is total heat load natin is 1.5. Divide natin doon sa area natin. Yung area natin is 80 square meter. So about 84 watts per square meter. So mapapansin nyo, no? 84 watts. Ayun, tama nga. Nasa medyo low side tayo. Between minimum and average. Andito tayo sa medyo tipid ng konti. So double check ulit natin, no? Sensible heat natin is 1.1 kilowatt divided by 8 square meter. We are getting 65 watts per square meter. Asan tayo sa rows of thumb natin? Ayun, no? Watts per square meter around here. So tama, consistent tayo. We're on the low side. Okay. So which means our calculation is sufficient for commercial offices. We are within the range of expectation according to our rules of thumb. This rules of thumb is taken from this book authored by Arthur H. Bell. So ito yung reference natin sa rules of thumb values natin. All right? Okay? Question? If there's no more question, this is where our presentation ends. Question pa ulit. Wala naman? Walang question? Our presentation is available sa Facebook Live. So it's being shared also in Facebook Live. For those who are watching in Facebook Live, if you have any question after this presentation, I will read them all and I will reply them all. Yung presentation slides natin, saka yung rules of thumb natin, yung reference natin, except for the ashtrays, saka yung codes and standards natin. The codes and standards I cannot share to you because those are proprieties. We need to pay. But the presentation slide and the rules of thumb, I can give. It will be given to those who have registered, regardless if you, as long as you registered, we will forward them to you. The presentation slides and reference material, the rules of thumb. Any more questions? Wala. Walang question. Dalawa lang yan pag walang question. It's either napakagaling ko o napakagaling ng estudyante ko. Ang gagaling ninyo, malamang. Thank you very much for listening with me today, for spending your Saturday evening with us. All right, we appreciate it. For those of you who want to watch the recording, we will send also a copy of the recording. It will be posted in Facebook Live, and it will also be available in my channel, in my YouTube channel, Don Gabriel. Our next session, our next training will be September 11. So medyo 2 weeks tayong bakasyon ng konti. September 11, watch out for our Facebook page. We have exciting trainings lined up, prepared for you guys. Okay. The next sa September 11 hindi pa siya part ng ACMV series. So after the September 11, just watch out. Just watch out on our Facebook page. When will be the next part of this ACMV series will be presented or will be scheduled. Okay. Be sure to go to our Facebook page and like and share and subscribe. Okay. Thank you very much. Again, if you have any questions, feel free to email me, to message me. And I will see you again on our next training session. Thank you very much.